Hello, I am Dr. Philip Barr, the lead educator of Thinking Beyond Education. Are you a Beyond Quantum applicant who has made it to the preparation stage? Or are you someone who wants to apply to Beyond Quantum in the future? Or maybe are you an independent learner wanting to start building your foundation to become a future expert in STEM, quantum physics, or quantum computing in particular? Then this video is for you. At Thinking Beyond, we have put together an extensive guidance and resources page that I want to explain in this video. It contains learning resources for beginners, but also top-level resources for graduates and postgraduates. Now, what is special about this resources page is that it is not just a collection of resources, but also contains an extensive guidance how to work through them and how to develop your thinking. Let's get started. Let's start with the resources page that contains the material we have put together for you as well as the guidance. Where can you find it? If you go on thinkingbeyond.education, then under Programs, Beyond Quantum, and then you scroll down a little bit, then here you can see the resources page. You click on this button and it brings you onto a Notion page that we have created for you. Now, as I already mentioned, this is not just a random collection of resources. It has also an extensive guidance how to use these resources, how to build expert knowledge, and how to think. First, you'll find a general guidance, what you need to do and to work through if you're interested in applying to Beyond Quantum program. And then here you find the resources themselves. The very first part is how to work with Notion, which is required for all programs. The second thing is just kind of general information about internet and AI. So if you're a very beginner to the STEM and you want to kind of learn how these things work. And what we really need to focus on for our programs are these last four: learning programming in Python and working with Google Colab, quantum maths. So what is the mathematics needed for quantum? Then we have resources for physics and quantum computing in particular. And then this is also something you will need in our program, is how to typeset in LaTeX. Let's have a look at the quantum maths. Let's make it bigger. Right, here we go. So as you can see, it starts off with the guidance, not just a collection of resources. And we would really recommend you read all of this carefully. So what is interesting for you is that the order of difficulty, or the order of requiring more and more knowledge and expertise, goes from top to bottom. So the more basic and elementary topics are on the top, and then they increase in difficulty to the bottom. What you also should know is that when you look at the collection of resources, the order is from left to right and then to the bottom, again increasing in difficulty. So on the top left, you will find the more basic courses, and at the very end, you will find the kind of more advanced resources. The resources contain materials for the beginner as well as postgraduate resources. So a question that we're typically asked is, am I not wasting my time with going through all these resources if I'm not taken as part of program? No, absolutely not. The prerequisites, and these prerequisites is what we list as the minimum prerequisites that you need for the program, they are part of what is considered basic knowledge if you want to become an expert in STEM subject to begin with. So learning these will at best accelerate your learning, but is certainly not wasted time and effort, because you will have to do them and learn them anyway. These maths resources, for example, they contain working with complex numbers, learning linear algebra, and in fact quite advanced linear algebra, at least from when you're a high schooler. And we've also added more resources relevant for quantum, like functional analysis and the mathematical quantum mechanics in quantum maths. In the physics section, we have also added more resources on quantum physics and quantum computing. Let's talk a little bit more how to work with these resources. Firstly, you will notice this is quite a lot. And if you're a high schooler, do not panic. We do not expect you to work through all of them. What is important is that you find the appropriate resources, right, that suit your current level. And then you work from there. You can then decide, first of all, if you're an applicant, you need to cover the prerequisites. But the moment you have the prerequisites covered, you can decide in which direction your interests take you. So what is it that you would like to learn more about and go in more depth? But let's talk about that later. Let me ask you the question. So with these resources, do you simply go watch the videos and read the articles? No. As one applicant very correctly remarked on our Discord, simply read book X or watch video Y is not sufficient to build a deep and profound understanding of a subject. It is not sufficient to build expertise. This is why we want you to approach and study with these resources from a researcher's point of view. What does that mean? It means to actively think, question, and link your learning, not just passively processing content and accepting what you're being told. Now, how to do that? Firstly, start by asking the questions why and how does it connect to what I know already. The why is a vertical and allows you to go into depth. The how is transversal, so it helps you to connect knowledge and your understanding across different fields. Now, this is not just important for you to be able to apply the knowledge that you've gained, but it also really helps you understanding and gaining retention. So this means that the things that you have learned will stick with you for longer and you will find it easier to remember. Now, this is very general advice and it applies to all kind of subjects. But of course, there's also subject-specific advice, like for mathematics and for physics. So how does the researcher's point of view look like there? Well, this is why we've written this guidance. So we have included examples like how you can think about the different topics and how you can approach them taking this researcher's point of view. And we've also carefully distinguished, again, if you're a high schooler, so that means that you do not know as much as of yet, or if you're an undergraduate where you've already had exposure to some of these topics. Be careful to not go too deep in one go, because then you will end up getting confused and you will feel lost. The right amount of depth is if you start feeling puzzled and you feel like, okay, I cannot answer these questions anymore. And even if I'm kind of doing my research and trying to answer these questions, I'm not understanding what is being said. So if you reach that level, it is important to move on to another topic and then eventually come back to answer these questions once you know more and understand better. So what should you do? Write down the questions and discoveries that you have done and then move on. As I said, it is an iterative process. So you're coming back, you deepen your knowledge, you're connected to new knowledge, and therefore you're building your expertise step by step. Now, you will learn more about the researcher's point of view in the program, and you will have plenty opportunity to practice and develop it. It's a trademark of my teaching, after all. Note that this is a skill, and skills need to be honed to achieve mastery. So doing and applying is key rather than just reading about it. If you happen to be completely unfamiliar with quantum computing, then we have left you a challenge where you can practice thinking of a researcher's point of view. So let's go on the physics tab. Let's go down to quantum computing. Rather than explaining to you what quantum computing is, we want you to actually figure it out by yourself, simply from knowing that it is a marriage between quantum mechanics and computer science. If you are familiar with quantum computing, you can attempt the challenge too. Try to reconstruct the basic ideas and challenges of quantum computing simply from the knowledge that it is a marriage of quantum mechanics and computer science as well. However, only use what you know about quantum computing and computer science. Be careful to not bring in any knowledge from quantum computing already. Your job is to rediscover it. We would recommend to write it up as a flowchart or a type of mind map and make sure that no hidden assumptions have crept into your argument. If you then want to see whether you reasoned correctly or how such a reasoning could look like, well then you can uncover the spoiler, where we go through different levels of what you could have reasoned. A very superficial level, then a deeper level, and then finally a level that would really require you to do an in-depth research if you reasoned up to this stage. Those students of you who are doing our preparation stage right now, be mindful of your time. Especially high schoolers. You should focus on covering the prerequisites really. As regards the more advanced linear algebra topics, it's good if you had a first exposure. Do not expect that you will understand everything. Why looking at them then in the first place? Well, this is necessary so you don't feel lost in the program when we use those notions. In general, we recommend you follow this order when covering the resources. First of all, you should make sure that you can code with Python and work on Google Colab. Then you should be really focusing on covering the prerequisites in quantum maths. Then look at LaTeX. And finally, look at the physics prerequisites in the physics and quantum computing section. Note that we have set no prerequisites for knowledge on quantum computing apart from the mathematics. We will teach that from zero in the program. Of course, considering the time constraints, you should be working on things in parallel. In particular, Python, math prerequisites, and LaTeX can be all done in parallel. Coming back to the researcher's point of view, be mindful that approaching your studying with the researcher's point of view takes time. If you're a high schooler who feels already overwhelmed by the prerequisites, focus on learning about them first, and then really about knowing what these things mean, rather than trying to go too deep. If you've seen them and have some familiarity with them, that will really help you for the program. You can then return back to studying things at a deeper level during the consolidation weeks or after the program, where you'll have time to apply and practice the researcher's point of view approach. If you're a university student, we expect more from you. You should go deeper. In particular, if you have covered the prerequisites in your university courses already. Once again, we have added resources up to graduate level, so no one should feel bored here. If you do find working with these resources overwhelming by yourself, we do have one tip and one good news for you. Top tip, join our Discord server. In particular, if you're an applicant, there is an active community of learners running study groups and working through these resources together already. Join them. Now the good news. We are planning to build courses more tailored towards beginners, which you can do to get started in the field or as a preparation to join our programs in the future. I'll add the links in the description once these courses are live. We hope that this will help you to navigate the resources page. Let me repeat it once again. Studying and building expertise is an iterative process. It requires dedication, effort, and time. You won't become an expert overnight. Perseverance is key. This means you have to come back, go over your existing knowledge, question it, connect it, deepen it, and then move on to learn new things again before you come back to repeat the same process. Gradually, you will deepen your understanding and build expertise in a topic or subject, I promise. If you're one of our successful applicants who have made it to the preparation stage, you have been sent an email with the link to the tracker. So let's talk about that tracker next. First of all, what's the point of this tracker? The main point is to introduce you to what is called Person Knowledge Management, or PKM for short. PKM is very important if you want to maximize the gains from your learning while you are building expertise. You will learn more about it in the program. Now, this tracker is a lighter version of a more sophisticated tracker you will get in the program. So one reason for this tracker is to get you used to using it and practice recording your insights. The second reason is relevant for your application. This tracker serves as a track record of your engagement with the preparation resources and will help us in making the final decision who we will accept into the program. Now, we have put a lot of explainers and guidance on this tracker, so pause them and read them carefully. So the very first thing you need to do is to clone this template to make it your own tracker. Let me show you how. You click on duplicate, and here it is. Notion will make a copy of the template into your own private Notion. For that, of course, you need to be logged in into your Notion account first. Let's do that first by adding in our name. And now you have personalized your Notion tracker. Let's talk about the application process next for which you need this tracker. First of all, as explained in this guidance here, you are currently at stage 2 of the application process. This means your job is to, first, make sure you have reviewed the prerequisites listed on the resources page we discussed before, do the required quizzes on the prerequisites, and engage with further resources once you are through the prerequisites or have covered them in another course already. Maintain the tracker by adding your notes and insights when engaging with the resources, and do weekly vlogs. Let's talk about the prerequisites next. Here you have a to-do list that can help you to kind of tick off and see all the things that you need to have covered, at least roughly. If you have covered these prerequisites already in another course, it's fine to add evidence of that in your tracker and either review them, taking a researcher's point of view, or move on to other resources. Use exercise sheets with your answers or exams with your answers as evidence and upload them on your tracker here. In this database, you can simply create new pages. For example, linear algebra. And you can say, well, I've done this in another course, so I'll mark this as done. Then I'll open the page, and here I can go and I can upload some image of, say, my exam in linear algebra if you have done it at university already. If, on the other hand, you have not covered what is listed in the prerequisites yet, just focus on the resources we shared with you to go over these prerequisites and upload notes, mind maps, quizzes, and your insights onto your tracker, like I've just shown. What about the quizzes? The links to the required quizzes are contained on this page of the tracker. So let's open it. Here it lists all the quizzes we want everyone to do, listed by the different topics. They are there to test your understanding. You can reattempt them as many times as you like as well. So if I want to do the quiz on the variables in Python, then I can simply click on the link and it will bring me to the question. The majority of those quizzes were set for you in your Khan Academy class. There are a few exceptions though. Under quantum maths, the complex numbers, vectors, matrices, and determinants are not on Khan Academy. Also, this worksheet on eigenvectors is not on Khan Academy because Khan Academy doesn't have a course or quizzes on eigenvectors. Now, although these 4 are Khan Academy quizzes, they cannot be set in your classroom, so therefore you will have to do them separately. We also made a quantum physics and quantum computing quiz, which you can find here at the very bottom. For each quiz, add a piece of evidence that you have done it. Make sure that everything is in English. Use Google Translate. It can also translate images. For the Khan Academy quizzes, that can be a screenshot of your results page once you have done the quiz. For the worksheet, just screenshot your page with the working out of the problems. Submit each piece of evidence under each quiz. So, for example, if I have now completed the variables quiz, I'll just go again, type image, then decide to upload a file, and that file should be the screenshot of your image of your result, for example. As regards the final quiz on quantum physics and quantum computing, if you do not manage to explore the basics of quantum computing, don't worry about the questions on quantum computing in the last quiz. Simply select I don't know. How do you put stuff on your tracker? We have just demonstrated it for you. Simply, you create pages in the Notion database, and again, you can do it like we've done for the programming in Python section, and you populate these pages with the evidence of your engagement with your nodes, with your mind maps, with your insights. Note that you can also use LaTeX. So, for example, here in linear algebra, you use $2 signs, then you type in your LaTeX code, and then you close with $2 brackets, and it's going to be rendered in LaTeX. We recommend that you create a static plan with the prerequisite topics you have to cover, the topics you want to cover, and give yourself internal deadlines when you want to complete each topic. Then create pages and subpages like we did for the review programming in Python. There is a final deadline on the 1st of March, but we recommend that you use other deadlines, so for example, tomorrow, right? So to structure your time. You can also, for your own convenience, use the status, whether this is not started, whether you're currently working on it, or whether this is done. It will also help us to see kind of maybe which resources you started but have not managed to finish until the end of the submission deadline. Let's have a look at the vlogs. What's a vlog? It's short for video log. What are they for? They're meant to document your learning journey. And this last part of the tracker is designated for your vlogs. Pause and read the guidance. What do we want to see? Well, first of all, nothing fancy. Film yourself while explaining what you have learned this week. Make sure to speak into the camera. Show also what you put on your tracker. The first 3 vlogs should be no more than a minute long. You can do it with your phone or with your computer using Microsoft Teams or Zoom if you have a camera. Once you have done your vlog, upload them on YouTube with selected with the option unlisted. And then share the link here in this table. Add the date, and you can also set the mood, how you've been feeling this week. If you upload your vlog onto YouTube as unlisted, you don't have to worry that someone else will be able to find it via Google or another search engine. Only us staff who can access your tracker, and anyone you wish to share the vlog with will be able to access it. No one else will be able to access it. Do your vlogs weekly. We expect you to have 4 vlogs spaced out over the 4 weeks of the preparation stage. Which particular day you upload the vlog on, this is up to you. The first 3 vlogs will be as described above, but the last vlog will be different. A week before the end of the preparation stage, we will send you a set of problems. 2 of these problems you'll need to write up in LaTeX using Overleaf. You'll have 3 problems, one on programming, one on quantum maths, and one on physics we want you to answer in your final vlog. So in your final vlog, you will need to talk us through your whole tracker and your learning journey. You will have to present and explain your answers to the 3 problems while facing the camera. Your final vlog should be no more than 3 minutes long. Spend 1 minute on explaining your tracker and the final 2 minutes to explain your answer to the 3 problems. So, how do you submit your tracker to us in your final submission? When we email you the problems, you'll also get a form where you can submit your tracker and your solutions on Overleaf. it will be imperative that you share your tracker correctly with us so we can access it. You'll find instructions on how to do it right on your tracker, where it also explains how to duplicate it. Let me show to you how this is done. So when you're on your tracker, you go on to Share, onto Publish, and then publish it onto the web. You then copy this link here, and you will paste this one into the final submission form. Now, as it says, let's check that our tracker or that we'll share the correct link. So for that, I'm going to open a new browser window, which is in incognito mode, or if you don't use Google Chrome, in protected mode, or whatever your browser calls it, so that your private data, your cookies, etc. are not shared across the tabs. This also means that here you're not logged in onto Notion, which is important, otherwise this test is not going to work. So now we paste in the link, wait, and we see that it loads the correct tracker. What is important is that you do not copy the link in here, yes, in your bar, on the top bar of your browser, but that you really copy the link, the publish link that Notion has created for you. Otherwise, it is not guaranteed that we will be access your tracker. And if we cannot access your tracker, we have to exclude you from the application process, since we cannot see the work that you have done. How can you remember all of this information? Well, all the guidance is on the tracker. If you have watched this video until the end, you should be able to recall what I said when you reread the instructions and guidance again. I hope that was helpful. Enjoy your learning during the preparation stage. Also, remember to join our Discord if you haven't done so already. People have already formed study groups to tackle the learning together. Join them.